Welcome to EDU World Space.
To evaluate this integral using limits and sums, we could first find delta x. Our b is our upper limit, which is 10, minus a, our lower limit, all over n. And that would end up giving us 8 over n. So that is delta x. And then we'll go ahead and write out the limit and the sum statement together. So it's going to be the limit as n approaches infinity of the sum from I is 1 up to n of, we'll go ahead and write the width, delta x here, which is 8 over n, and then multiplied by this x to the sixth. But to start that off, we actually need the lower limit is where we need to start, which is 2 plus delta x times I, so it's going to be plus 8i over n. All of that is then going to be to the sixth. So at this point, we could use a computer program to evaluate this. And let me go ahead and highlight what I plugged in first. So then I plugged this in first, the sum, and that turned into basically, let me go ahead and write out just the first term, because only the highest power of n really matters here. The rest of the terms get knocked out. So it's going to be this. How many nines? 1, 2, 3, 4. And then 616, all divided by 21. And then that was times n to the sixth. And that was also divided by n to the sixth. There's more terms here, but they have lower powers of n. So for instance, times n to the fifth. And then when you take the limit as n approaches infinity, these are all going to go to 0. These n's to the 6 will cancel. So our solution is really going to be this. And it turns into a couple things that are all the same. So another way to write that using approximation is 1428 553. 0.1, and then it keeps going 4, 3. And if you were to plug this into an algebra system, or basically like a graphing calculator, and evaluate that, it'll end up giving you this exact value here. Well, this approximate value here, I should say. So it's pretty cool how you can see the sum and the limit do result in the correct value here as well.